All right. Last time we went over in fairly good detail, the select statement. The select statement is sort of the workhorse of SQL because it's responsible for the queries. And I guess I would say that it is probably the more complex of all the statements there are. The insert, the update, and delete, excuse me, are actually a little more straightforward. And we'll talk about them, I don't know, either today or maybe on Tuesday next week. But I want to continue on with select. What makes the select statement so complex is that there's a handful of clauses, maybe 8, 10, something like that. But the way that those clauses can be put together and the variety of things that you can use, never mind the fact that you can get into creating subqueries, where you nest queries inside each other and things like that. All those things make select statements, give them sort of the potential of being pretty complex. All right? And that's good. That's really where the power of relational databases come from, because we can take data that's stored in the optimized best way and present it any way we need to the users. The more flexibility we have in performing queries and presenting it to the users, the better formatted that can be, and we can provide better information to our users. So, I'm going to pull up, I hope I saved the Word document from last time. I did. I'm going to pull that up so that we can start looking at these tables and start talking about joining tables together, which is a whole nother issue. Now, in SQL statements, if there's more than one table, you have to specify how the tables are connected. Now, you might think that given the fact that you define foreign keys, that's enough. You might think, well, it's going to know how to connect them because it's going to connect them based on foreign keys. It doesn't work that way. And it's probably a good thing, because if it forced you to do it a certain way, it's liable to make some decisions. Anytime something happens automatically, it might force some decisions on you that you don't want. So once you learn how to do it, it's not that big a deal. Just remember that when you write a query that involves multiple tables, you have to join them one way or another. Let's look at a different set of tables to start this out, because I want to talk about what happens when you do not properly join them. So, if we had tables that look like this, employee, and in it we had an employee ID, first name, last name, and department ID, primary key, foreign key, and our department table looked like this. Let's say we have 4 employees in 2 departments. We'll keep it simple. So, employee 1, Mike Zellers, is in department 1. Employee number 2, Mary Jones is also in Department 1. Employee 3, Ann Smith, is in Department 2. And employee 4, Mark Alberts, is also in Department 2. Our department table then might have Department 1 being CISS and Department 2 being accounting. Now, we have to join these tables together for this to work. All right? And I'm expecting that this is review, but I do want to make a few different points here. By joining them together, there's a couple ways that you can do it. One of the ways is via the where clause. All right, we'll talk about the advantages and disadvantages of doing it. Chief advantage of this is something you already know, right? You already know the where clause. It's not anything new. When you did 143, did you use where clauses to join things together? Or did you use the join clause? Did both? Okay, good. Good. Okay, I usually go over this because it's a little more straightforward, although it's a little less flexible. So, to do a join a simple way, that's what we'll start out talking about. You would do something like this. I could say select first name, last name, department name from employee, department, where employee dot department ID equals department ID. Then I can say order by department name, L name, and F name. So, a couple things to note. My list of columns can come from either of these two tables. I list the two tables that I want as part of the from clause. So I could have two, as many tables as I need to in the from clause. So what we talked about last time still applies. This is a list of columns. This is a list of tables. All right? Now there's a little bit of a difference here. All right? List of columns are separated by commas. List of tables are separated by commas. There's a little bit of a difference here because I can refer to a column two ways. Just like I could refer to people in the classroom two ways. All right? The full name of a column is the table name dot column name. Just like your full name, we'll forget about middle names for now, right? But your full name is your first name and your last name, right? And let's say, for example, I were to say, Justin, raise your hand. Okay, that worked, right? There's no confusion. Why? Because there's no one else in this room named Justin. So, if there's no one else that has the same first name, all right, I can just say, Justin, raise your hand, and you know that it's that person. Are there two people in the room that have the same name?
Could be.
Are there any Mikes? Let's hear some first names.
Jessica.
Justin.
Angela.
Jared. Stanley.
Candace.
Jaden. Mark. Jason.
Darn. If for most of last year I called Jaden Jason, or Jared or something, I got his name wrong. So let's imagine how about this? Jaden, pretend your name is Jason. Okay?
Sounds similar.
Sounds similar, right. So if I said Jason, raise your hand. There'd be confusion because there's two people named Jason. So I could clarify that confusion by using the first name and last name. All right? And most of the time that would work. Again, we're going to forget the case where there could be two people with the exact same first name and last name. All right? That doesn't happen in databases. All right? And in a situation like this, it would be pretty unlikely. So we're going to forget about that situation. So there's two ways that you can refer to a column, either by the column name or by the table name dot column name. Now, F name. I can just say F name. Why? Because there's only one column that has the name F name in the room. All right? What do I mean by in the room? I mean between these two tables. F name only exists in one of these tables. So I can just say F name. Likewise with L name. Likewise with department name. So all of these, I can just use the column name. But I could also give the full name if I wanted to. It would be okay if I used your first name and last name if you're the only person in the room. All right? So an alternate way of writing this would be employee dot F name. Employee dot L name. And department dot department name. And that's fine too.
So would you have to write that in the select and the order by?
No, you mix and match. All right. So like one time I could go by this. One time I could give your full name. One time I could just give your first name. All right. It's smart enough to know which is which. Now, there are situations where you have to give the table name and column name, and that's a situation like this. I couldn't say where department ID equals department ID, because that would confuse the database engine. Because which department ID are you talking about? Because there are department ID fields in both tables. All right? Does that make sense? Should be pretty intuitive. All right? Should be pretty intuitive. If you forget to do that, it will tell you, like if you forget to put the table name in front of a column that exists in more than one table, it will tell you it doesn't know which one you mean. Might not use, depending on the database, it might not use that clear of language, but it will give you an error message. Now, notice a couple things. Here, here, and here are all column names. You don't have to select something to use it in the where clause, or for that matter, to use it in the order by clause. All right? It might be confusing. If I had no order by clause here, or, no, let me rephrase that. If I didn't display the department name and still ordered it by department name, it would look confusing because it would have the employees sequenced by their department name, but you wouldn't see the department name to see, oh, that's how they're sequenced. you would just see employees A through Z of one department, then employees A through Z of the next department, then employees A through Z of the next department. So it wouldn't look like there's any rhyme or reason. All right? So typically, if you're going to order it by it, you're going to also include it up here, because then you can look at it and it'll make sense. Oh, okay, that's why it's sorted in department name. But again, I don't have to select the department ID to include it in the where clause. All right, so I would expect this, and this to be clear. All right? Any questions about the select part, the from part, or the order by part?
Is it best practice to always say the table name first?
Well, that's a good question. Some people prefer to do it that way. And if you want to do it that way, that's fine. I would say it makes it more clear. All right? In other words, at a glance, if I was looking at the SQL statement and I was debugging something, it might not be clear to me that F name comes from the employee table and department name comes from the department table. Oh, well, department name would be pretty obvious, it came from the department table. But F name, I don't know, could be file name, whatever. All right? And in other cases where the columns are maybe a little less straightforward, a more involved example where the column names weren't quite so obvious, it might be difficult. So if you want to always put them in, that's great. I probably out of laziness don't. All right, I just typically use the column name just for the ease of typing in. But yeah, some folks consider it good practice to put that in front of there. One thing that we don't talk about too much in here is programming standards. All right? We kind of talk about what makes for good code, and we talk about commenting your code, and we talk about how to define a function and what makes for a well-designed function. But some organizations, especially larger ones, have programming standards. And that could be a programming standard for an organization. Always use the table name, column name for that. The main thing I would say about standards is as long as they're like clearly documented and they're consistently applied, almost any standard will probably help a little bit. All right? I worked for one organization that had very sort of extreme standards. They had a list of words, almost like a dictionary, along with how you should abbreviate it in the column name. So, customer was always abbreviated CUST. So, anytime you saw customer, it was abbreviated CUST. And maybe address was abbreviated ADR. So just looking at that column, cust ADR, you could look at a dictionary and say that means customer address. And that's not a bad idea, especially for a large organization where you're going to have potentially a lot of developers working on the same thing. You know, these, again, are very obvious names. Anyone looking at those could probably get what they stand for. But in larger databases, more complicated, a little less obvious data, it would be good to have some sort of naming convention for that. Okay, now for the where clause. The where clause normally is used to filter stuff out. All right? Remember last time we did a bunch of selects where we selected based on the year purchased for the computer. So we said where year purchase equals 2017, or year purchase greater than 2017, or year purchase in 2015, 2017, 2019. All right? We did them a couple different ways. All of those had the effect of filtering out stuff. So we're not going to see every computer. There's no where clause. We're going to see every row. So in that case, we would see every computer. When we add the where clause, we filter out. We say we don't want to see everything. We just want to see these items where these conditions are true. Using a where clause to accomplish a join does the same thing. All right? What that's going to do is that's going to return where it matches up the department IDs in the two table. Without a where clause, guess what the database engine would do? If I had no where clause here, what would the database do? Well, I tell you what it would do. It would match up every row in the employee table with every row in the department table. All right? Because we didn't specify how they're linked together. So we would get how many rows in our result set? We'd get 8 of them. All right? We'd get, this is what our output would look like. We get Mark Alberts in accounting, Mary Jones in accounting, Ann Smith in accounting, and finally, Mike Zeller's in accounting. And if that doesn't give me shivers, I don't know what would. Then, it would repeat them. Mark Alberts in CISS, Mary Jones in CISS, Ann Smith in CISS, and finally then Mike Zeller's back home where he belongs in CISS. That is called a cross product. That comes from some kind of like higher mathematics. It's called a cross product, where you match up everything in one table with everything for another. Now, if we had 3 tables, I don't know, home office, that maybe had 5 rows in it, how many would our output be if we didn't join those? If we included from employee, department, home office, and we didn't join them together? There's 5 rows in here. 40, right. We would get these 8 things repeated for each office. All right? So you can see if you're joining multiple tables together, if you forget your where clause, you're going to get way more data than you expected. In fact, that's a good rule of thumb. If you ever run a query and you get a lot more data than you expected, look at your joins. All right? First thing to look at, because maybe you forgot to join something. All right? And again, for every table that you have, there's going to be, if you have X tables, there's going to be X minus 1 things in the where clause to join them together, more than likely. All right? If there's 2 tables, you better have 1 thing in the where clause, at least, that joins them together. This is assuming single part keys, by the way. If you have 5 tables, there better be 4 things. Essentially, you're making a path. This table to this table to this table to this table. That's why if you notice an ERD, most of the time it's going to be very rare that you have a table out there by itself. All right? There's a way to get from any table to any other table, And that way you can join them together if you have to do a query that involves all those tables. So, rule of thumb, if you know you only have 4 employees and you run a report that shows you have 8 employees, look at the joins because it's probably repeating the employees and it's not associating something. So, now let's put the where clause back and see what happens. Where employee department ID equals department ID. All right? Now, even though we didn't select it, Mark has a department ID of 2, accounting has an ID of 1. Mary has a ID of 1. No, I'm screwing this up. Mary has, accounting is 2. So all these, the department ID is 2. And 1, 1, 1, 1. So these aren't being displayed, but associated with these rows, this is the department, this is the employee's department ID. Mark is 2. Ann is 2, and the rest are 1. Mark is 2, Ann is 2, and the rest is 1. So this is actually the data that it's retrieving. Now, if we include that where clause, what's happening? We're going to exclude the rows where the IDs don't match. If the IDs match, we're going to keep it. So we're going to keep this one. We're going to exclude this one. We're going to keep this one. We're going to exclude this one. We're going to exclude this one. We're going to keep this one. We're going to exclude this one. We're going to keep this one. So it might be a little hard to read, but we keep only the 4 employees. Because just like we did with filtering out by year, we're filtering out and only including the things where the department ID matches the employee's department ID, where the department ID in the department matches the department ID in the employees table. Make sense? Okay, so we need to join stuff together for it to work. All right? And one way of joining it together, there's multiple tables, a couple ways to join it together. One way to join it together is via a where clause. Now, here's a limitation of a where clause. Let's say we have one employee that doesn't have a department. They haven't been assigned yet. Okay, maybe they're a new hire. We don't know where we're going to put them. If we run this query, how many are we going to see? How many employees are we going to see? We're going to see 3. This guy doesn't have a match in the department ID table because they don't have a department ID. Therefore, they're not included in the results. All right? I could write all that up again and you notice they'd have nothing and the department ID would be 1 or 2. Neither 1 nor 2 matches nothing, so this guy would be excluded. When you use the where clause, there has to be a match all the way down the chain for something to appear. All right? So even if I joined with the 3rd table for home office or something like that, an employee would have to have a match in the department table and a match in the home office table for it to appear. If they were missing one of those, if it was not a required field and they didn't have it, they would not appear if I joined it together. This is called an inner join, when there has to be something in each of the tables for the join to work. So when you use this syntax, you get what are called inner joins. The more complex way of doing a join, you can write inner joins like this, if that's what you want, but you can also write outer joins. All right? We could correct that, by the way, if we wanted to, by just saying or employee department ID equals null. But that would be complicated if you had a multi-part join, because you'd have to check all the way down the line. Much easier to do this part of it with the other syntax for the join. But again, there's always a way, right? There's always a workaround. All right, let's get back to our examples, our tables that we use. All right, let's say we wanted a list sorted by building code, subsorted by building number, that showed us the building code, the building name, and the room number for every room on campus. So we want to see the building code, the building name, and the room number for every building, for every room on campus. So that would look like this. Oh, protected view. So, what columns do we want? We want building code, building name, and room number. So notice how that works. The select, then a list of columns. Let's make sure I spelled them right. Building code and building name. Yes, I did. By the way, SQL is not case sensitive. So if I defined it like this, and I wrote the SQL statement like this, there's no problem, which is kind of nice. From building room. All right. Can I just say building code, building name, and room number? Yes, I can. Because building code and building name are only in the building table. Room number is only in the room table. I could, if I wanted to, of course, put the table name in front of it. And that would work just as well. Now I'm going to need a where clause, right? So I'm going to say where, and I have to link up those two. How do we link up those two tables? They both have a building ID in them. The building ID is a foreign key in the room table, and it points to the building ID in the building table. So I'd say where building ID equals room, building ID. Now, if I did that and it would run, I don't have any guarantees about the order that they would appear in. It would appear in the order that the database more or less felt like giving it to me. So I'm always going to put an order by in, and that's pretty good practice as well. And I'm going to order by building either code or name, whichever one we thought was better. Let's order by building code and room number. So that's how that statement would look. All right. Let's see. Let's look at another SQL statement. Let's say I want to see every computer, what building and room that computer's in, the year purchased, and the price. So, what tables do I need? The computer is linked to the room table. That will give us the room number. And then I need to go to the building table to get the building code. So, my select would look something like this. Select, what I'd say, computer ID, year purchased, and price, along with the building code and the room number. Some people like to write their selects with just one column on a line, and that works too, makes it easier to read. Remember, you're welcome to do what makes it easy for you to read, because code that's easier to read will be easier to change. So whatever you think makes it easier to read, good for you. So we'll stretch this out. From computer building room, what would the where clause look for this? What would the where clause look for this? We have to make a line from the one table to, we have to include all the tables in sort of a line. So, what can we join computer table to? Yep, we can join it using the room ID. So where computer room ID equals room ID. I'm deliberately leaving something out. Now, are we going to connect these with ands or ors? Connect them with ands. In other words, all of them have to be true. That link has to go all the way through. Not this link go through or this link go through. I'm not even sure what it would give you if you connected it with an or, but it wouldn't be right. This is where the little workaround I put up in the board would be awkward, because I would have to include this in parentheses, like there's a computer not assigned to a room. I'd have to say this, or computer room ID equals null, and then do the same thing with that. So that gets really, really hard to read. As I said before, this would work and it would give us computers listed in some order. We would probably want it ordered in some specific order. So maybe we would order it by building code, room number, and then within a room by computer ID. Questions about this? All right, here's a challenge. I want you to think about this for a minute and tell me when you think you know the. We'll think about it for a minute and then we'll see if anyone has a solution to this. What if I wanted to see computer, year purchased, and price, along with building code and room number, for every computer that was purchased before 2017? So I want to see, same thing I had before, except I only want to include the older computers. Computers purchased before 2017. Let's think about it for a minute. How would we do that? Any takers? Let me guess. Everyone found out yesterday that Mario Kart is available on mobile devices, which it is. And you were up all night playing it, and now you're exhausted, and your brain's not engaged to answer these trivial questions because you're trying to clear the next level. I hear you. I'm there, right there with you. All right? Any thoughts? Yes.
You want to add something to the where clause?
All right.
Where your purchase is less than
Yeah, where your purchase is less than 2017. So you're absolutely right. The first thing to do is identify where that's going to go. All right? And remember, this is the list of columns. Well, we're not changing what columns we want to see. All right? So we don't need to change that. We're not changing what tables we want the data from. So we're not changing that. We're not changing the sequence that we want the output in. So we're not changing that. The only thing that we're changing is how we're filtering these computers. Right? We don't want to see every computer with its matching building and room information. We want to see where, in addition, the year is 2017, is earlier than 2017. So what do I type here? And. Not an or, right? But an and. And we would say price, not price, I'm sorry, year purchased, less than 2017. So that would go and that would add that. So you see, when we use a where clause, the where clause sort of has two purposes. In general, the where clause is used to filter out stuff from the results. But that filtering can either join two tables, or that filtering can simply restrict the output that's given. So in this case, we use it for both. These two match up the room and building with the computer. This one filters out the computers that are purchased prior to 2017. Okay, here's a question. I want to see a list of building codes, room numbers, and how many computers are in that room. So I want to see something like BU 210, 16, BU 212, 14, BU 202, 18, or whatever. I want to see the building code, the room number, and the number of computers in that room. All right, let's take a minute to think that through. That involves combining stuff we talked about today with stuff that we talked about on Tuesday. So we'll take a couple minutes, think it through, and then we'll discuss our answers. Well, I want everyone to think it through, and then we'll discuss it. Wait a couple more minutes. So try to get as much of it, try to think through as much of it as you can, and then we'll review it. All right, let's think this through. We want to see building code, room, how many computers it has. So I'll start you guys off. What's next? Building code. Room number. And what? Count. Star. You could put count star is fine. Count computer ID would also work in there. But usually for count I put a star. Okay, so far so good. Now what? I'll give you this one too. From. Building. Computer. All right. Now this is interesting because we don't have listed up here any thing from the computer table, but that's what we're counting, so you know we have to include the computer table. All right, what's next? Where?
Building ID equals room.building ID.
Mm-hmm.
And computer.room ID equals room.room ID.
Yep. We're doing great. Anything else? Group by. Excellent. How did you know there needed to be a group by? Because there's an aggregate function and there's some things on the select line that are not an aggregate function. All right? And what would we put there? Mm-hmm. Yep, would put the things that are on the select line that aren't part of an aggregate function. And that is correct.
You can also put in order by.
No. No order by on this. The group by sort of works as an order by. So if I say this is an aggregate function, it will give me this in order by building code and room number. You typically only use the order by if you're not dealing with aggregate functions, because the group by takes care of the sequencing. I don't think it would hurt it, it's just not necessary. What if we wanted to see only the rooms that had more than 10 computers? Yep. Having count greater than 10.
Does it matter the order that you put that in?
Yes. The clauses go in a certain order. I'll Google it, but generally select from where, order by would be here.
I found on the web.
Oh, be quiet. Sometimes I think my phone is sarcastic. I think it really is. Especially when I'm driving, I'm using GPS and I make a wrong turn. I swear I can hear a tone in its voice. Like, make a U-turn in 300 feet. And at any rate, yeah, order by would be next, although it's not really necessary. Then group by, then having. I don't know if there are any more clauses. Let's really Google order of clauses in SQL. Select from on. On and outer are different ways of doing a join that we'll talk about next time. Where, group by, and then finally distinct as the last. I'm not really sure what the select down here would be. So yeah, pretty much that. They do have to be in order. All right. Let's say I have a given computer. Computer ID 1234. All right. My computer ID is 1234. And I want to see a list of all the applications that are installed on computer 1234. I want to see the application code and I want to see the application name. All right, same thing. Think about it for a second. So I want to see, and I want to see them in order by application code. I want to see, that it has Audacity, AUD, which is Audacity, CH, which is Chrome, and so on down the line. So I want to see a list of applications on computer that has an ID of 1234. Let's wait just a minute or so longer. All right, let's run down the line. First word, select. Now what? App code, app name. Next, from, application, computer. Anything else? An application computer. All right. Next. Where?
The computer ID equals 1234.
Actually say where, I have to say where computer ID equals 1, 2, 3, 4. Next. And
Computer ID equals app.
I'm sorry, repeat that.
Application computer ID.
Application computer ID. And I have to connect the application
Application
computer, yeah.
app ID equals app computer app ID.
And then I would need the order by. That would say order by app code, app name. Okay, we're joining 3 tables together. So that means that how many parts are there going to be in the where clause that do the joining? It's going to be 2. So to join 3 tables, you need 2 parts of the where clause. Part 1 and part 2. And this is just the filter because we want to see the computer, a specific computer as opposed to all computers. Now, question. This is a correct answer. Is there a way we can do this a little bit differently? You can almost tell the answer is yes, right? Otherwise I wouldn't have bothered asking. How can we do this just a teensy bit differently? Give you the same results. Not really a big deal either way, but for understanding, I want to make sure we understand this.
Talking about inner joins or
No, not that. No, just using the syntax we have now, just not changing the way we're doing the join or anything like that. We could do something to change this query, and it would produce the same results. Do we really need the computer table? That sounds like a weird question, right? Do we really need it?
I guess not, since your computer ID is on the
Yeah.
application.
I guess not, because first of all, I'm asking about it. And second of all, because the computer ID is on the application computer table. So, I could actually write the same thing like this. Eliminate the computer table. Change this to say we're computer application. Computer ID equals 1, 2, 3, 4. And application computer app ID equals application app ID. Makes it for a slightly simpler statement, it involves a little less of a where clause, probably would run at least a little bit quicker. But other than that, produces the same results. Questions about any of this? Now, if I said if I said that I wanted to do this for computers that were purchased before 2017, then I'd have to have the computer table in there, because then I'd be filtering by something that only lives in the computer table. One suggestion, by the way, don't use spaces in your table or column names, okay? Because that can cause you grief. Because let's say, for example, the application computer table is named application space computer. If SQL sees that, it sort of thinks that those are two separate things. The way to get around that is to put square brackets around it. So if your heart's absolutely set on having spaces in your table names and so on, you can do it, and you can put the SQL statements like that. But generally, it's a better rule not to. I don't even know if the slash is permitted. The slash probably isn't permitted. So this table name probably would need to change. Maybe with an underscore instead. If you want to put a space there for readability, like if you had a long table name and you wanted to run together, use underscores instead of a space. Just don't use spaces, ever. Even like in memos and stuff, just run all the words. No, I'm kidding about that. I had actually students in my University of Akron Java class, and so many of them get in trouble because they were like including spaces in different things, spaces on the path or spaces whatever, and it's like the space as part of a name of something, typically every program in the world thinks a space means that you've ended one thing and started something else. So therefore, just avoid spaces. That goes with web pages, that goes with CSS files, JavaScript files, anything like that. Just avoid them. All right, any questions about this? I will go and unlock the door of the lab. Then I'll be over there. If there's something you want me to grade, give me a holler. I don't have my laptop, so you will need to bring it up on your machine. If it's an ERD you want me to grade, or if anyone is far enough along where they have the SQL statements, print them out and bring them up to me. I sort of apologize.